All the numbers you come across during a day can be written using these 10 digits. We are so accustomed to using numbers that we rarely ask ourselves, for example, why we write 37 like this, a 3 and a 7. You might find it interesting to know that 37 can also be written in these 3 ways and also more. In this video, we are going to see how numbers entered human life and how they evolved. There's a tribe called Piraha in Brazil who don't have many words for numbers. These people, most of whom are hunters, have limited words to express numbers. A few, not many, and many. Daniel Everett, an American linguist, tried to teach these people how to count, but not even one of them could learn how to count from 1 to 10. They didn't even manage to add 1 to 1 and do the simplest arithmetic possible. Using these numbers is so evident for us that we barely become curious to know how we came up with using these symbols to show the concept of numbers. Take a moment and think about the numbers you use today. What did you use them for? If I ask you how many eyes there are on our faces, you would probably say 2. And if there are 3 of us and I ask you the same question, you will add 3 2's and say 6. But if I tell you to show me the numbers 2 or 6, whether you have to use symbols like these or some words. These are some abstract concepts that cannot be presented objectively. And that's why we should use some symbols or maybe use our fingers, an objective presentation, to show them. Now it's time to see what we have done as human beings to come up with these numeral systems that we use today. In 1950, a bone was found with a lot of markings deliberately carved on it. It seems that it dated back to 20,000 years ago, and they used it to keep track of the days of a month. The bone, called Ishango bone, seems to be the first mathematical tool used by man. However, another bone, Lebombo bone, was found in the 1970s, dating back to 40,000 years ago, which is also said to be used for counting days. There's a lot of debate about these bones. With all that said, the first numeral system can be attributed to Sumerians and was later adopted by Babylonians 2,000 years before Common Era. These two civilizations were located in Mesopotamia, a region we know as Iraq today. The numbers Babylonian used were like these. This symbol was Babylonian presentation of 1, and this one was the representation of 10. All the other numbers in this base 60 system were formed using these two symbols. In order to understand how Babylonians illustrated numbers, you need to get familiar with a concept called positional notation, that Babylonians were the first to use this concept. Let's first start with a simple example that is more familiar to show what positional notation is. I can write this number as the sum of these numbers, 30,000, 6,907, meaning that the numbers 3, 6, 9, 0, and 7 are multiplied by different powers of 10 from right to left, incremented by 1 in each step. It means that if we had another number after 3, we would have to multiply it by 10 to 5, and add it to 36,907. This kind of representing a number is called writing it in base 10, which is an example of positional notation. Changing the positions change the number. 37 can be written like this in base 10. How do you think we can write it in base 5? We have a 25 in 37 and what is left is 12. 2 5s yield 10 with 2 of 12 left. And the remaining 2 go there. So in base 5, the number is 122. 37 can also be written in base 8 and base 16 like this. Let's illustrate this number in a more visual fashion. 2 packs of 1 plus 2 packs of 5 and finally a pack of 25. But as you can see, this kind of representation takes up a lot of space. If we divide 37 by 5, we will have 7 packs of 5 and 2 packs of 1 left. Now let's divide these 7 packs of 5 by 5 to categorize them in a pack of 25. As you can see, 2 packs of 5 are left and there is a pack which contains 5 packs of 5. and there are two individual ones remaining from the previous step, which yields this number 122 in base 5. Now it's your turn. Try to write 37 in base 2, which is called the binary system. What you need to do is divide 37 by 2 as long as the quotient cannot be divided by 2 anymore. Then put these numbers from left to right, respectively to the lowest position up to the highest one. And this is 37 in base 2, or the binary system. The symbols we use for different positions depend on our base system. For example, for base 4, 5, and 6, we'll need these symbols to put into different positions. Or for base 16, we need 16 symbols from 0 to 9 being the conventional decimal system numbers, and for 10 to 15, we use the letters A to F. For example, 2024 can be written in base 16 as 7E8. Babylonians used a base 60 system for their numbers. Pay attention that they have 59 symbols for 1 to 59, and there is no symbol to represent the number 0. The symbol we use for 0 today was first introduced by Indian mathematicians like Brahmagupta in their calculations. However, Babylonians realized that they needed such a concept. In fact, if they used this symbol in a position, it meant that they wouldn't consider it in their calculations. But why 60? Why did they use base 60 for their calculations? One of the reasons is that 60 is divisible by all these numbers, which makes calculations really easy. We can still see the presence of their system in today's world. Each hour is 60 minutes and each minute is 60 seconds. Or for example, a circle has 360 degrees, which facilitates showing different angles. There is another benefit to base 60 numeral systems. If you use your thumb as a counter, 3 numbers can be counted on each of your fingers, adding up to 12. By counting 5 times, we would reach 60, and counting can be easily done by using our hands. Now it's time to write some Babylonian numbers. There are 3 positions. The right one is 60 to the power of 0 or 1, the middle one is 60 to the power of 1, and the left position is 60 to the power of 2, which is 3600. For example, this is the number 2. And this one is 62. This is 70. There are 10 ones and 160. 3601 can be written like this. Note that in the middle position, the symbol shows 0, or not having the middle position. The biggest number using 3 positions is the case in which there are 3 59s in the 3 positions, which gives 215,999. Let's go to 3000 years BCE, even 1000 years before Babylonians. That ancient Egyptians used these symbols to show numbers. For example, this number contains 2 hundreds, 7 tens, and 3 ones, which yields 273. These symbols are called hieroglyphs. Pay attention that this kind of numeral system is not based on positional notation. Now, look at this face. Can you believe that this was once a number? Mayans used such symbols to present numbers. As you can see, they had a symbol for 0 and their numeral system was base 20. Maybe because we have 20 fingers and toes all together on our bodies. Mayans wrote numbers vertically and the positions were based on 20. For example, these numbers are 239 and 2644. The next civilization we want to talk about is ancient Rome, and I think you have seen their symbols before. For example, World War II can be written like this, and this friend of mine is 2. These are the symbols used by Romans to show numbers. For example, to write 2, they put 2 ones together. For 3, they added another 1, but 4 was written as 5 minus 1. Put an I before V and it shows 5 minus 1, which is 4. And if you use I after V, it shows 5 plus 1, which is 6. Consider this number, 1984. It contains 1984, which can individually be shown as you can see. And finally, this long number is 1984. Pay attention how long can numbers be in this kind of representation. And finally, decimal numbers that you are familiar with. Around the 4th century, Indian mathematicians used this kind of notation in their calculations, which was then used by Persians and Arabs in the 9th century and was introduced to Europeans by Fibonacci about 13th century. What I told you in this video was just a brief history of what happened to numbers. My goal was to make you think about how we have used our brain's ability to create such abstract concepts by carefully looking at our surroundings, and these concepts are developing every single day. If you would like to know more about the history of numbers, I suggest you to take a look at this book, which was written by a math teacher. I hope you like this video.